Airflow begins as the air is drawn into the engine through the air filter. The air leaving the air cleaner enters the turbocharger. The rotating blades of the turbocharger increase the pressure and temperature of the air. The air leaving the turbocharger flows through piping across the top of the engine and then forward to the charged air cooler. In the cooler, the intake air gives up the heat to the ambient air flowing over the outside of the cooler. The air leaving the cooler flows through piping to the intake manifold. When a two-pump, two-loop cooling system with aftercooler is used, the intake air flows directly from the turbocharger to the intake manifold. During the intake stroke, the downward motion of the piston draws the air into the cylinder. As the piston begins its upward travel, the intake valve closes, trapping the air in the cylinder. The upwards motion of the piston squeezes the trapped air, causing an increase in pressure and temperature. As the piston nears the top of its stroke, fuel is injected into the cylinder. When the fuel comes into contact with the high-temperature air, it begins to burn. The combustion of the fuel generates the high pressures that drive the piston downward, thereby creating power. As the piston nears the bottom of its stroke, the exhaust valve opens. Upward movement of the piston drives the burned gases out of the cylinder and into the exhaust half of the turbocharger. The exhaust gases leaving the engine contain a considerable amount of residual energy. Some of this energy drives the turbocharger turbine. The turbine, being on the same shaft as the compressor, drives the compressor, which draws more air into the engine.